All right. Hello, guys. Good morning, good afternoon, good evening, whatever it is you're joining us. Today, we're going to be discussing section 8.4 from your packet. It's on anion formation, and of course, this comes from your CK12 packet. How do you make chlorine safe to eat? I don't know if you know, but chlorine is pretty dangerous gas. If you inhale it or if you come into contact with it somehow, it can be very harmful. The same thing happens for sodium. If you ever drop sodium into a bowl of water, it can react violently. And when we say violently, it can, kind of explode. And I think we've seen a video where somebody dropped a piece of sodium in water and it broke the container that it was in. Okay, so both sodium and chlorine can be very dangerous on their own. But what happens when you combine them? Who's going to help me read? Who's going to volunteer to read, please? Oscar? Uh-oh, we're having the same trouble as last time, Alexia. Is it me or is it what? Oscar, can you unmute? Or Mario? Just to test out if I can hear you? Because I can't hear you. No, I can't hear her. Okay. Hold on. All right, let me pause this real quick. All right, go ahead.
How do you transform a deadly gas into something you can sprinkle on your eggs and eat for breakfast? Chlorine in its green form is very dangerous if you breathe the fumes or come in contact with the gas. However, after reaction with sodium, we have sodium chloride form as a sodium atom gives up an electron to chlorine with attacks the electron to form the chloride. Can you say this?
Anion.
Anion.
Very good. Thank you, Miss Alexia. All right, guys. So if you ever come into contact with chlorine on its own, it can be extremely dangerous. Just like it said, if you breathe the fumes or you somehow touch it or get exposed to it, it could do some harm to you. But once it undergoes a reaction with sodium, right? Sodium loses an electron, chlorine gains the electron. You make ordinary table salt, right? And we put table salt on just about everything as Hispanics, right? We love it on our beans, we love it on our tacos, we love it even sometimes on, I don't know, eggs and potato and everything else that you guys love. But either way, once chlorine and sodium has undergone that reaction and become the compound sodium chloride, you have a very safe and tasty substance. Okay? And today, that's what we're going to be talking about. We're going to be talking a lot about how elements gain electrons. Excuse me. Anion. Anytime an element gains electrons, you're going to call that an anion. And what is an anion? They are negative ions or elements, right? Formed from gaining of one or more electrons. Sorry. And why do they want to do it? Well, when nonmetal atoms gain electrons, they often do so until their outermost principal energy level achieves octet. Remember, the magic number that every single element on the periodic table wants in its outer orbital and its outer energy level is 8. So for nonmetals, they have a tendency to say, hey, gimme, gimme, gimme. Why? Because I need to make octet, and I'm almost there. Okay? Nonmetals, they usually have more than 4 electrons, so it's going to be easier for them to gain electrons than it is for them to lose electrons. Okay? energy-wise, I'm talking about, right? It takes less energy to gain 3 or less electrons than it is to get rid of those electrons, or to release them or lose them, whatever you want to call it. This process is illustrated below for the elements fluorine, oxygen, and nitrogen. Okay, so the first thing I'm going to ask you to do is we're going to go to a periodic table and we're going to identify the number of valence electrons for the element fluorine. Okay, so if I go here to the periodic table, look for fluorine and tell me, students, how many valence or what group number is fluorine in? And once you know the group number, technically you should know the valence electrons for that element. Go. Find fluorine, guys. Give me the group number for that element, and you should be able to give me the valence electrons for it as well. Anybody find fluorine? Remember, we're talking about nonmetals. We're talking about the right side of the periodic table. Anybody see fluorine? Fluorine, the letter F. Group 17, right, Oscar? All right. So if I have fluorine who's in group 17, right? This is your group number. My question is, how many valence electrons for that group? Do you remember? What do we do when we're talking about valence electrons? What do we? Very good. You remove the 1 in front of the 17 and you're able to decide or to decode or to find the number of valence electrons. In this case, our valence electrons is 7, right? All we did was we took off the 1 in 17. All right. So now that you know that, Oscar, you can see them here in the electron configuration. If you look at period 2 or energy level 2, you have 2 orbitals. You got the s orbital that has 2 electrons, and then you have this p orbital that has 5 electrons, right? You can see them right here. If you add 5 plus 2, that's the 7 electrons that Oscar was talking about. So, how many more electrons do you need to gain to make an octet of electrons? How many more do I need in order to make octet? You need to gain just 1, right? If you gain 1 electron, just like you see here, fluorine, 0 charge, it's gaining 1 electron, right? Because we have a plus, and we end up with a -1 charge. Remember, the number of electrons is going to be the number that you have for your element's charge or your ion, right? Because once it gains electrons, it becomes something known as an ion. And you can see here, I used to have 5 electrons in the p orbital, and now I have 6. If I add the 2 from the s orbital, I have the total of 8. That is what we call octet. Now, let's talk about oxygen. Oxygen. Find oxygen on the periodic table. What group?
16.
Thank you. All right. So if we have oxygen now with in group 16, right? This is the group number. Oh man, what am I spelling? How many valence?
6.
Right. So I got 6. That is not a V. I got 6 valence electrons, and you can see them in the PowerPoint here or in the presentation in your electron configuration if you look at energy level 2. Energy level 2, the s orbital has 2 electrons. In the p orbital, I got 4. That's a total of 6, right? Just like they said earlier. So my question to you is, How many more do I need to gain to make the octet that everybody wants?
2 more.
Definitely 2 more. And you could see it because they've already written it down in an equation. You have oxygen with no charge plus 2 electrons, and look at what you end up with. A -2 anion for oxygen. And then if you count up your electrons, 6 plus 2, that is the octet that it needs. The last one, nitrogen. What group is nitrogen in? Find nitrogen. 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 Anybody see it? Remember, you're looking at the nonmetals. Nonmetals on the right side. How many valence what group number and how many valence electrons for this element? Nitrogen. Anybody see it? You're looking over here on the right side of the periodic table, guys. Oscar, you don't see it? Irvin? Yalexia? Nitrogen, element 7. Element 7. I'll give you the atomic number.
Group 15.
Group 15. There we go. Finally, you guys get it. All right, so we got nitrogen. It's got group number 15 again. How many valence electrons? Yes, ma'am. 5. 5, right? 1, 2, 3, 4, 5. All right, and you can see it here in the presentation. Here in the electron configuration, 2 in the s orbital, 3 in the p orbital for a total of 5. How many more in order to make octet? Huh? Octet is 8.
5.
5. You already have 5. You need to make 8, Irvin.
Oh.
How many more do you need? How many more electrons?
3.
Yes, sir. So if you have nitrogen with no charge and you add 3 electrons to it, it's going to end up with a -3 charge, just like you see here. And that's going to give you the octet of electrons that you need. All right. All of these, hold on. Okay. All of these anions are isoelectronic with each other and with neon. They are also isoelectronic with the 3 cations from the previous section. So yesterday when we talked about sodium, magnesium, and aluminum, they all ended up with the same electron configuration as neon. We said that they were isoelectronic. The same thing is happening here. These 3 elements are gaining electrons so that it can have the same electron configuration of neon. And that's what we mean by isoelectronic. It's going to have the same electron configuration of another element, in this case, neon. Under typical conditions, the 3 electrons is the maximum number that will be gained in the formation of anion. So what it's saying is that more than likely, about 95% of the time, the maximum number of electrons that can be gained is 3. There are some exceptions, as always, but they're not very common, okay? They're not common. So we always like to say the maximum that you can gain is 3. All right, guys, you have your first pair deck question. Are you ready? It says circle the correct answer choice. Anions gain or lose electrons in order to complete octet. Oh, excuse me. Start circling your answer. I got one person who already put in their answer on Pear Deck. Irvin, if you want to join us on Pear Deck, go ahead. Let's see what they answered. Gain. Does everybody else agree or disagree? Raise your hand if you agree with this answer. Irvin agrees. Who else agrees? Mario, do you agree? Oscar agrees. Yeah, Alexia, do you agree? Thank you, Irvin. You can put your hand down. All right, I guess we're not listening. I asked a question. There we go. I'm not talking about you, Alexia. I'm talking about Hania, Mario, Yaslin, and Ephraim. I asked a question to the whole class, and we're not having a response. Make sure you're listening, guys. Yes, that's the correct answer. Anions gain electrons. Oh. I wanted to talk about the little picture real quick before we continue. So here, this little picture on the bottom, I forgot to talk about it. It says here, cats are good. That means positive, right? If cats are good, they are positive animals. So as you can see, this little cat, this little kitty right here, has plus signs for his eyes. Why? Because cats are good, just like cations. If you're talking about anions, remember that onions are bad, right? That means negative. So if you've ever done this before and you cut up an onion, it makes you cry, right? And when you cry, that makes your eyes look like little negative signs. I prefer a much easier method. For me, I always tell my students, guys, what does the T look like in cation? And I think I've mentioned this before, but I'm just going to mention it real quick. Remember, the T in cation looks like the plus sign for the positive charge, right? And for anion, I always say N is for negative. Okay? So if you know that you are gaining electrons, you better have a negative charge for that element. Okay? So that's just a quick reminder or to help. That's how I learned it when I was in school. And I've been studying chemistry for a long time. And I suggest that that's the way you remember it. The T in cation means that it's going to have a positive charge, and the N in negative, N in anion, means that it's going to have a negative charge. Okay, keep that handy. It can help you later on. All right, let's move on to the next question. All right, this is your next question. Write down the anion formation for the following elements. And we got chlorine, phosphorus, and sulfur. All right, so find chlorine on the periodic table. What group? Chlorine. What group? What group is chlorine in? Group 17. Very good, Alexia. Okay, so if I have chlorine, he's in group 17. How many valence electrons? Very good, young lady. Very good. All right, so I'm going to draw the little 7 electrons that it has. And I know they're horrible electrons. But my question is, Alexia, how many more electrons does chlorine need to gain in order to make octet? You got 7 electrons, but you need an octet of electrons. How many more do you need? Very good, Oscar. Oscar says chlorine needs to gain 1 electron, but my final question is, what's the charge of chlorine? What's the charge for chlorine? I know it has a negative sign, okay, because it's an anion, because it's gaining. But my question is, what's the number that should be there? -1, -2, -3, negative what? How many electrons did we gain? So that is the number that you are going to have for chlorine. When it gains that 1 electron to complete octet, it's also gaining a -1 charge. Make sense? I hope so. Remember, the number that you have here, the number of electrons that are being moved or that are being gained, that is the number that you're going to have here for your charge. Does that make sense? I hope it does. Okay, next question. Phosphorus. I need the group number. Phosphorus. Group number. Remember, we're talking all about non-metal, so you're looking at the right side of the periodic table. What do you think, Oscar? Group 15. Thank you, Irvin. Okay, so now I have phosphorus. Irvin says group 15, and he's right. It is part of group 15. Valence electrons, Irvin? Yes, sir. Okay, so now I take off the 1 because that is what we do. We got 5 valence electrons. What do I need to do in order to get my octet? Yes, sir. We're going to gain 3 electrons. So my question to you, what's my charge? -3. Yes, sir. Yes, sir. Remember, the number that you have here is the number that you're going to put at the top. So for this guy, it's a 3 that gets moved here. And since it's gaining, it has to be negative. It has to be negative. Why? Because those electrons have a negative charge. So it gains a negative charge. Okay? All right, one more. I believe the last one is sulfur. Find sulfur on the periodic table. Group 16. Man, you're on fire today, Irvin. Okay, so we got sulfur, group 16. How many valence? 6. Yes, sir. Okay, I got 6 valence electrons. What's going to happen? You gain 2. Yes, sir. If you gain 2 electrons, what's your overall charge for sulfur at the end of this process? That's going to be -2. Yes, sir. Everybody understand where that number comes from? Anybody have any questions as to how we're getting that -2? No questions? Good job. All right, so now that we've completed our practice, let's finish up the presentation. Outer electron configurations are constant within a group, so this pattern of ion formation repeats itself for periods 3, 4, and the following. So let's talk about a little about yesterday, a little bit about today. If we are in group 1, that means we have 1 valence electron, right? It's a metal. We know metals lose electrons. When you lose 1 electron, you change that into your charge. In this case, a +1. And everybody who's part of that group is going to have the same charge, from lithium all the way to francium, +1. If we're talking about now group 2, we got 2 valence electrons. Again, it's a metal. Metals have a tendency to lose 2 electrons. It's going to leave you with a +2 charge, all the way from beryllium down to radium. If your group's 13, 3 valence electrons, again, you're still metals. Metals lose. You have a +3 charge. Group 14, can't really predict it. I would use the valence sheet for that. Group 15, 5 valence electrons, you're going to gain 3 and you're going to gain a -3 charge. Why? Because nonmetals gain electrons. Okay? If you're group 16, you got 6 valence electrons, you need to gain 2, right? You need to gain 2 in order to make 8. You gain also a -2 charge. Group 17, 7 valence electrons. You gain that one little electron. One little electron. You also gain a -1 charge. Everybody in that group should have the same charge. Okay? It is important not to misinterpret the concept of being isoelectronic. A sodium ion is very different from a neon atom because of the nuclei of the two contain different number of protons. So just because the electron configuration is the same for sodium ion and neon, that doesn't mean they're going to react the same. No. It's those protons that you originally had don't change. You still have the same number of protons, and you are going to react differently when you compare sodium anion, sodium cation to neon. They're going to have very different properties. Okay? Just because they have the same electron configuration does not mean they will react the same. Protons make a difference. One is an essential ion that is part of table salt, while the other is an unreactive gas that is a very small part of the atmosphere. Likewise, sodium ions are very different than magnesium ions, fluoride ions, and all the other members of this isoelectronic series. And they give you the series in parentheses. Nitrogen -3, oxygen -2, fluorine -1, neon no charge, sodium +1, magnesium +2, and aluminum +3. Neon gas in picture A, and in picture B you have sodium chloride crystals. And remember, sodium chloride is just table salt. Neon atoms and sodium ions are isoelectronic. Neon is a colorless and unreactive gas that glows a distinctive red-orange color in a gas discharge tube. Sodium ions are most commonly found in crystals of sodium chloride, which is known as ordinary table salt. Questions before we continue? Questions? I don't like this one. I want this one.
Texas area.
Learned about ionic compounds, but have you thought about how they form and how they get their charge? I'm Layfish from layfirsci.com, and in this video, I'm going to show you exactly how ions form and how they get their charge. Before we get into how ions get their charge, we have to discuss why ions want to get a charge. And this all goes back to the octet. The octet rule, as the word implies, is the rule of 8, and this says that every atom wants to have a complete outer shell of electrons form a complete octet. world, there are exceptions to the octet rule, but let's focus on just the standard atoms for now. Here's a trick for recognizing the valence electrons on the group A elements. When you start counting from the left, the first group will have one valence electron and the second group will have two. This trick does not apply to transition metals because the way their electrons are organized is a little bit different. Moving on to 3A, we have three valence electrons, 4, 5, 6, 7, and 8. The reason I put the number over helium, when you're looking at electron grouping, helium actually fits right here next to hydrogen. It's on the right because it's a noble gas, but it only has 2 rather than 8 valence electrons. Going back to the octet rule, the noble gases are happy. They have their full octet. What about the rest of the atoms? Looking at something like sodium or chlorine, they don't naturally have a full octet, so they have to go out of their way to find that octet. We'll start with sodium and recognize that it has an atomic number of 11 and that it's located in the third period on the periodic table. If we draw the nucleus of sodium, we'll write Na and give it a plus 11 because the atomic number tells me how many protons I have in the nucleus. We'll draw a small circle to represent the nucleus and now start drawing in the electron shells. The first shell is going to have 2 electrons because the smallest shell can only hold 2. The second shell can hold a total of 8 electrons, and that means if we already have 2 and 8, that's 10. That means the 11th electron will be by itself in the outermost shell. Going back to the octet rule, if sodium has 1 valence, 1 outermost electron, how is it going to get 8? We can think, okay, sodium will steal an electron from another atom, and then another one, and then another one. The problem, though, is the more electrons that an atom steals, the more energy it has to use up. And sodium, or any atom, does not have enough energy to take 7 electrons. So instead of taking electrons from another atom, sodium will simply give up its outermost electron. By giving away that electron, we lose not only the electron, but the entire shell that came with it. If we look at sodium now, after giving away that electron, the next outermost shell has a total of 8, and that means sodium has a full octet and it's happy. Now that it has a full octet, we have to account for what happened when the electrons give it up. So let's do a quick balance of charge. If sodium has 11 protons, that means it has a charge of plus 11 in the nucleus. Now sodium only has 10 electrons, and that means we have a charge of minus 10 in the electron cloud. When we subtract 10 from 11, we get a net of plus 1, and that means sodium now has a charge of plus 1. If an atom has a charge by gaining or losing electrons, that's what we call an ion, and that means the sodium is a plus 1 ion. Looking back at the periodic table, let's see what happens when we analyze chlorine, which has an atomic number of 17 and is also located in the third period. We'll start with the nucleus, which has a charge of plus 17 due to its atomic number. And then we'll follow the electrons. When we're looking at a neutral atom, the atomic number equals the number of protons and also equals the number of electrons because it's neutral. The first shell has only 2 electrons, and that's because the first is the smallest shell and can't hold more than 2. The second shell is going to have a complete set of 8 electrons. That gives me a total of 10. If we already have 10 electrons, and we need a total of 17, we simply add 7 electrons to the outermost shell. Going back to the octet rule, if chlorine wants to have 8 in its valence, but it only has 7, that means we're missing 1. Unlike sodium, which was able to give up 1 electron, chlorine is not going to give up 7. That's way too many electrons to give away. So instead, chlorine will find an atom such as sodium that is willing to give up an electron and take the electron from that atom to complete its outer shell. When we add in that electron, the octet is now complete, but we no longer have an equal number of protons and electrons. So let's calculate. We have a charge of plus 17 in the nucleus, and that's because the atomic number is 17, which gives me 17 protons. We now have a charge of minus 18 in the electron cloud, and that's because we have the 7 initial electrons and the 1 that we added. When we subtract 18 from 17, we get minus 1, which means that chlorine with a complete octet is an anion with a charge of minus 1, or simply CO-. If you understand what I've shown you, you can now apply this to every single atom within the group A elements. However, on an exam, you're not going to have time to actually go and calculate each one. So let me show you a trick that has to do with valence electrons on the periodic table.
All right, guys, this trick is really handy. So if you have an extra periodic table, which you should have in your packet, whether it's packet 1, 2, or 3, all 3 of them have a periodic table. Go to that page right now and start writing down what she puts in red at the top of the periodic table. Okay? Go for it.
If an atom has one valence electron, like the sodium atom we looked at, that means it has one electron that it can give away to refer to the shell that's underneath for a complete octet. And that means group 1 is going to form +1 ions. If we look at group 2, they have 2 electrons to give away. And that means they're going to form +2 ions. Jumping over to group 3, they can form +3 ions, and that's where we'll stop. An atom like carbon, which has 4 valence electrons, is going to be torn between, do I give up electrons or do I steal electrons? So carbon is likely not going to form an ion, instead it will form a covalent bond, which is the topic right over here. Now let's move over to the right. We said that noble gases are full, so we're not going to apply a trick because they don't form any ions. Noble gases are going to form a charge of 0. They don't form charges. But then these will have 7 valence electrons. And just like chlorine, we'll want to steal one more and form a charge of -1. Moving to group 3 on the left, these can receive 2 electrons and so will tend to form a -2 ion. And group 5 will tend to form a -4 ion. Slightly enough charges of 2 or more, so ignore that. Remember, you count from the left, +1, +2, and +3, and you count from the.
All right. So this is what you need to write, because I can ask you any element within these groups and you should be able to tell me the charge. If I ask you for selenium, element 34, -2. Iodine, element 53, -1. Calcium, strontium, +2. Okay? All right.
All right.
Stop there. Okay, I'm going to leave that up real quick because we're going to need it. And let's summarize the topic. Anions are negative ions formed by accepting electrons. The outermost principal energy level is usually an octet. And then your questions that we're going to answer, and they're really easy. What is an anion? 2, write the electronic configurations for chlorine atom and for chloride anion. What does isoelectronic mean?